Okay, so hi students. So we have finished first chapter, drawing function of real variable, and in this video we are going to start with some special integration, and the first one is Gaussian integration. So today we will look for one dimensional Gaussian integration and we will see some its extensions. After that we will go for multi-dimensional or you can higher dimensional Gaussian integral. Okay, so please see the further video. Integration of e to the power minus x square dx. This type of integration is called Gaussian integral, where we are taking the limit from 0 to infinity. Fine. So this type of integral is called Gaussian integral, one dimensional Gaussian integral. Now we want to evaluate the value of this. So how will you do this? So in your 10+2 you learned to evaluate the integral of this kind, not exactly this kind, some exponential or logarithmic or trigonometric function. What you are doing in your 10+2 is that you are doing a method which is called by-part integration, where you applied the first second rule and you did the integration, but this particular integral cannot be evaluated with that method. So to evaluate this integral, there is another method by making this integral into a two-dimensional integral. So let us see how we can make it two-dimensional. So suppose this is I1 and we write here another integral of the same kind 0 to infinity e to the power minus y square dy. So I1 and I2 both are Gaussian integral, one dimensional Gaussian integral, and x and y both are different coordinates, independent coordinates. Okay. So we are going to take here the product I equals to I1 and I2. So this integral will look like a two-dimensional integral e to the power minus x square minus y square dx dy. So this is a two-dimensional integral. Fine. Now we are able to evaluate this integral. There is a method called coordinate transformation. So right now this integration, the integrand of this integration is in terms of x and y, which are in Cartesian coordinate. Now we will change this coordinate system to r and phi, which is plane polar coordinate. Okay, so how we do that? We have a transformation rule. We told you already in last video that so this coordinate transformation rule from Cartesian coordinate system to plane polar coordinate system is x equal to r cos phi and y equal to r sin phi. Correct? Now we want to evaluate this integral, this I, fine. So we will do a coordinate transformation. So here our integrand is in this so let us write the integration again. I equal to 0 to infinity e to the power minus x square plus y square dx dy. Correct. So if you evaluate this x square plus y square, this is equal to r square using these two transformation rules. Fine. Correct. Now we want to evaluate this elementary area. So this dx dy is called elementary area in Cartesian coordinate. Now we want to evaluate this in how will you write this elementary area in plane polar coordinate. How will you do that? So to do that, there is a method called Jacobian matrix and we take the determinant of that. So let me write that. So elementary area in one coordinate system is related to another coordinate system by a factor of Jacobi factor. This is Jacobi factor. and this is dr d phi. So, we have to evaluate this j. How will you do that? So, this j is actually a matrix called dx dy dr d phi. So, this matrix is actually look like dx by dr d phi dy by dr dy by d phi. So, this is Jacobian matrix. This matrix relates one coordinate system to another coordinate system. So, we have to evaluate each element here, this element, this element, this and this, and we have the relation between x r. So, we have already the relation, this relation which we have this relation. So, using these two relations, we will evaluate the matrix elements J. So, the value of derivative x by derivative r will be, if you do the partial derivative with respect to r of x, that will be r cos phi. So, this will become minus r cos phi. Fine. If you evaluate derivative x by derivative phi, that will become minus r sin phi. Do the integration, and derivative y by derivative r. So, this was y equals to r sin phi. So, this will become sin phi only, and this will become plus r cos phi. Now, put these R four element in Jacobian matrix and take the determinant. So, if you do so, J becomes, the determinant of J becomes R cos square phi minus, and this minus R sin phi, which is nothing but R cos square phi plus sin square phi. If you are not understanding these steps, please pause the video and do the calculation by your own. You will understand then. This will become r. So, the Jacobian factor comes out to be r. So, now what will be the elementary area? Dx dy will be equal to r dr d phi. So, this is actually the elementary area in plane polar coordinate. Now, let us return to our integration. So, our integration was I equals to 0 to infinity e to the power minus x square plus y square dx dy. So, in plane polar coordinate, this integration will become e to the power minus r square r dr d phi, correct. Now, what you have to do is that take the phi integration outside and do the, so this is now now one more thing, we have to change the limit. Since we have done the coordinate transformation, accordingly we have to change the limit. So, I put, this is suppose x axis and this is y axis. So, I put the limit of x from 0 to infinity, and in case of y we put the limit 0 to infinity. So, we are doing the integration in first quadrant. So, in case of plane polar coordinate, this integration will become for phi. So, I told you in some previous video that phi is an angle from x axis. So, phi is an angle from x axis. So, this is phi, correct. So, if you increase phi from x axis to this way, so this is 90. The limit of phi is actually vary from 0 to pi by 2, limit of phi, and value of r. So r varies from 0 to infinity, because because x is varying from 0 to infinity, there is no limit, upper limit on x, there is no upper limit on y, you can go up to infinity, that is why r also go to up to infinity. So the now the limit r, so for case of phi it is 0 to pi by 2, and for the case of r it is 0 to infinity. Good. And this is I. Now e to the power minus r square, and the integration of phi is actually 0 to, so this will become pi by 2, and this is r dr, correct. Now think, do the integration of r square, sorry, take the first derivative of r, so this is nothing but 2r dr, correct. So if you understand this step, then you can just do a manipulation. So this will become 0 to infinity e to the power minus r square, and this r dr will become dr square by 2, and do a substitution rule again. Suppose you change the variable from r square to z. If you do so, so you will see that this integration becomes become pi by 4. You take this 2 factor outside, 0 to infinity e to the power minus z, and dr square is equals to, so dr square equals to dz. So you put here dz. Now you do the integration of e to the power minus z, which is nothing but e to the power minus z with a minus sign. So a minus sign comes outside, and you take the limit from 0 to infinity, which is nothing but pi by 4. You first put infinity, then e to the power minus infinity is 0, and e to the power 0 is 1. So this becomes 1. So I is equals to pi by 4, correct. Now this is I equals to pi by 4, where I is equal to I1 times I2. Now I will tell you that I1 is equal to I2. You will ask question, why I1 and I2 are equal. So see the integration I1 and I2. So here you see that this I1 and this I2, here in both integration x and y are dummy variable. What do you mean by dummy variable? So dummy variable means that since if you do the integration, this integration I1 and I2, the final answer will be independent of x and y. Why? Because if you do the integration over dx over x and you put the limit of x from 0 to infinity, the answer, the value of I1 will be independent of x, and similarly for I2 the value will be independent of y. Hence, and the form of both integration are same, the structure of both integration is same. So only the difference is that one is in terms of different variable, another is in terms of another variable. So if the value is independent of variable and the structure is same, that is why we call it, we can say that these two integration are equal, the value of these two integration is equal, fine. So hence, so this I is nothing but I1 square or I2 square, which is pi by 4, hence I equals to root pi by 4, correct, and which is nothing but root pi by So, we evaluated the value of that integration, which is e to the power minus x square dx from 0 to infinity. The value of this integration is pi root pi by 2, correct. So, we done up to this point, we evaluated this value. Okay, so now we will do a extension of this integration. So, we will include a factor of constant parameter in the exponent. So, this integration, the new extension look like e to the power minus ax square dx. So, you can evaluate this. How will you do? Just do a substitution rule, ax root ax, substitute this variable with the new variable z, and do this a root a dx equals to dz, and the limit will be same. Fine, you can check. If you put x equal to 0, z will be 0. If you put a equal to x equal to infinity, z will be infinity provided a is greater than 0. So, here we are going to evaluate this integration provided a is greater than 0. So, in that case this integration becomes 0 to infinity e to the power minus ax square dx, and which is nothing but root pi by a 1 by 2, correct. Fine, and you can see here, if you are asked to evaluate from minus infinity to plus infinity e to the power minus ax square dx. So, you can see here that this is an even function, and that is due to because this is an even function, you can change the limit from 0 to infinity e to the power minus ax square dx and make it 2 times, and this will become 2 times 1 by 2 root pi by a. So, if you change the limit from minus infinity to plus infinity, and this integration becomes root pi by a. Fine. Okay. So, we did an extension of this integration. This is also Gaussian integral. Fine. So, this integration is also valid for any complex number, valid for any complex number a. So, if a is not a real constant, a is a complex number, then this integration is also valid provided real part of a is greater than 0. So, let me explain this, why it is necessary that if a is some alpha times I beta, this kind of complex number, then why we require that real part of a is greater than 0, then this integration will be valid. Why not if real part of a is less than 0 or something else, correct. So, to focus on the integrand of the integration. So, here for the Gaussian integral e to the power minus x square. So, this is our integrand. Fine. So, if we try to plot this integration, this integrand. So, if you want to plot it, how it behaves over the x axis, we want to look for that. So, suppose this is your y axis and this is your x axis, and here you want to plot y equals to e to the power minus x square. So, at x equals to 0, this integrand value will give us 1, because e to the power 0 is 1, correct. Okay. And if you increase the value of x, e to the power minus infinity is 0. So since it is x square, if you go minus x side or you go plus x side, in both case x square will be positive and there is a minus sign in front of x square. That is why if you go to minus infinity or plus infinity, in both cases the integrand will become e to the power minus infinity, which is 0. So this integrand, the behavior of the integrand, something looks like this. Fine. So in the whole range of x-axis, the value of this integrand, which you are calling here y, is finite. So for all value of x, y is finite. What is y? Our the integrand, e to the power minus x square. Correct. So because it is giving the finite value, integrand is finite at every x, and now you are choosing different integrand, and which is e to the power minus ax square. So to evaluate any integration, it is necessary that in the range of integration the integrand must be finite. Otherwise, what will happen, that integration will diverge. So to evaluate any integration, it is necessary that in the whole range of integration the integrand must be finite. So here, if we introduce a, it is necessary that it does not alter the sign of this exponent. If a is a real constant, fine, and a is positive, then in that case the sign of this exponent will not change and this integrand will be finite over the whole x-axis range. But if a is negative, in that case over all x-axis, whole x-axis, if a is negative, then this integration will become so if a is negative, this integration will become mod a x square, because this minus sign and this minus sign will become plus, and this integrand will diverge for x equals to plus minus infinity, because at x equals to plus minus infinity the integrand will be mod a, the exponential. If you are, so earlier if a is positive, the integrand is minus a x square, where this integrand become g tends to 0 for x equals to x tends to plus minus infinity. But e to the power mod a x square, where a is negative, in that case this integrand diverges to the infinity for x tends to plus minus infinity. So if integrand diverge, how will you evaluate the integration? That is why it is necessary that if a is real constant, then it must be positive, and if a is a complex number, if a is a complex number, then it is necessary that real part of a is greater than 0. So let us look why it is necessary. So integrand a alpha times I beta x square, you write a equal to alpha times alpha plus I beta, any complex number. So you can break down this integrand into the some product e to the power minus alpha x square e to the power minus I beta x square. So here alpha is a real part of a and beta is a complex part of a, imaginary part of, sorry. imaginary part of A. Fine. So this is an e to the power minus I beta x square is also a complex number, but this is a real number. Fine. So our integration now, if A is a complex number, is a product of these two numbers, one real number and one complex number. Fine. Okay. So if alpha is, if alpha, this alpha is not, if greater than 0, then this real part, real number will be finite. Okay. If alpha is not less than, not greater than 0 or less than 0 or equal to 0, in that case, so suppose alpha is less than 0, in that case this real number will diverge for x tends to plus minus infinity. So e to the power minus alpha x square will diverge. So if alpha is less than 0, then this will diverge to infinity for x tends to plus minus infinity. So our integrand will not be finite, then how will you do the integration? Okay. Okay, so till now what we learned is that e to the power minus x square dx equals to root pi by 2, the limit is from 0 to infinity, e to the power minus ax square 0 to infinity dx is equal to 1 by 2 root pi by a. Fine, where a real part of a is greater than 0. One more extension we want to look for, and that is e to the power minus ax square plus bx, and you do the integration over x from 0 to infinity. So, or you can say from minus infinity to plus infinity. So what will be the value of this? So I leave you this for you. I will tell you how to do this. If you are not able to do this, I will tell you in the next video. So how to evaluate this integration. So if you look for it, the value of this integration is root pi by a e to the power b square by 4a, where real part of a is greater than 0 and b is any complex number, and b is any complex number. Fine. So since this video is becoming lengthy, that's why I am not giving you the derivation for this. In the next video I will tell you the derivation for this. Okay. So I leave you to do this integration before the next video, so that you can verify in the next video. Okay. Thank you very much.